Okay, this is the learning video on right triangle trig. On the left side of the paper, you see, or the screen, you see definitions we talked about in class. And on the right side, I would say these are the basic ratio problems. As you guys know, the board hasn't been working very well, so we'll see how it goes. I may have to start typing. So just take a minute to read the left side and remember that one of the things we talked about was the abbreviation. So SOHCAHTOA, a lot of people use to help remember the trig ratios. So S stands for sine. Sine is the opposite over hypotenuse. Similarly, cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. Okay, over here, some problems are just very, very simple. And I printed a worksheet and attached it to the website that goes with this. So I'm not going to do every problem. That would be really painful for you, but I'm going to do a few of each. So in exercises 1 through 4, give each answer as a fraction in terms of P, Q, and R. Darn it, it's already not working. So if you look at problem number 1, the sine of P, the goal of the problem is just to identify P. And I'm going to go to the computer and type here. Identify P, and then remember what it means to be the sine. And you look at the triangle, and opposite is P is little p, and the hypotenuse is R. So the answer for problem 1 is just a fraction of P over R. You just leave it. That's the whole answer. And similarly, if I wanted to do problem 3, problem 3, it's asking for the tangent of P. So tangent is opposite over adjacent. So instead of P over R, you have P over Q. So that's all it is. It's just that simple. So that's the basic ratio type problem. Down here, there's a little bit more work, because in order to do, for example, problem 5, you need to find T. And so here's angle T. And then to do the sine of angle T, you have to find the opposite, which is 8, but you need the hypotenuse. So this is a 6, 8, 10. So the sine of T would be 8 over 10, but you would reduce it, and so your final answer would be 4 over 5. That's the whole problem. Similarly, cosine of T would be the adjacent, which is 6 over hypotenuse. So 6 over 10, or 3/5. So those are the very basics. Okay, here's the next step. So I moved the definitions to the right because I think the smartboard sometimes works better on the left. So to do a problem like number 9, we did some of these in class. This is just a calculator problem. You're solving for the variable x, and so you think of this as a ratio and proportion. So you cross multiply, and you multiply by what's on the diagonal without the variable and divide by the leftover. So in this case, you would just say 28 times the cosine of 64 divided by 1 is equal to x. And you pick up your calculator, you make sure it's in degrees, and my calculator's in degrees, and I just type in. On your calculator, every calculator works a little bit different, but 28 times cosine So on this calculator, I have to put the number in first, and on your calculator in class you won't. So it's not going to be the exact same, but I have to actually put the degrees in first on this calculator and take the cosine of it. It's like an old-fashioned calculator, and then multiply it by 28. So you practice that with the calculator that you have. And the answer, we're going to express each answer accurate to the nearest 100th. So it's good. So in looking at my answer on the calculator, to the hundredths place, I would say x is 12 and 27 hundredths. So problems 9, 10, 11 are just ratio and proportion problems. So you might think there's a slight difference between 9 and 10 because the variables in the denominator on 10. Let's shrink this up a little bit. But we've done ratio and proportion all year, so we're going to still cross multiply and divide by what's left over. So in this case, x is 12.1 times 1, which is just 12.1, and we're going to divide by the sine of 24. So again, we're going to pick up that calculator, clear it, and I'm going to do 12.1 divided by, and remember, my calculator works different than the TI in class, so I have to put the 24 and then hit the sign, and then hit equals. So you can practice with the calculator in class tomorrow. So the final answer there, to the nearest hundredth, is 29.75. So x is 29.75. And you need to see where I got the 5 from. I rounded up. The next problems down here, these are just calculator practice problems. So if you have something like number 13, remember in class today, talked about using the inverse function. And I'm spacing this out because when you're trying to find the angle, you have to undo the trig function by using the inverse function. In other words, I'm going to take the inverse tangent of both sides. And that's how I write it. And then the inverse tangent of the tangent is just b, because inverse functions undo each other. So really, all I need to do is type in inverse tangent of 4/3 on the calculator. So I'm going to bring my calculator back up, and I'm going to do 4/3, and then I'm going to hit the inverse tangent. And I get 53. And the directions here say find the measure of each angle to the nearest degree. So 53.13 is just rounded to 53 degrees. So that's the simple process of using the calculator. So then we get to more using trig. So when you look at problem 15, and if these are a little small, print the worksheet up, because this worksheet is also posted on the website. So if I want to do a few of these, I always look at the variable that I'm trying to find, and then in reference to W, I have an angle and a hypotenuse. So I have to think in terms of the angle. So in reference of 40, I have the side opposite and the hypotenuse. So that's going to be the sine. So I write a true statement. And my true statement is the sine of 40
is equal to the side opposite divided by the hypotenuse. And then I just put a 1 here, and I solve the ratio and proportion. So I'm going to do 28 times the sine of 40 is equal to W. And I type that into the calculator. I follow the rounding directions. So 28 times, and remember on my calculator, I have to put the 40 in first. But you can practice with your calculator. So 17.998. And when we read the directions, it says to the nearest tenth. So 17.99 to the nearest tenth is really 18.0. So that's the final answer. I just made that a little smaller to fit. W is 18.0. We'll do one more over here. If I want to find y on problem 17, I'm going to look at the angle that I have. And in reference to that, I have the adjacent and the hypotenuse. So the true statement would be the cosine of 17 is equal to the adjacent, 73, divided by the hypotenuse. And then I put a 1 there. So my work is just 73 times 1 divided by the cosine of 17. So I pick up the calculator, and I do 73 times 1, which is 73, divided by the cosine of 17. And I get 76.335, so to the nearest tenth, y is 76.3. And the units would be centimeters here and centimeters over here, by the way. Okay, so, in looking at problem 18, we'll do problem 18 here. This goes back to circles, and we have a circle, and we have a diameter, and so we know that inscribed angle is a right angle. So if we just focus on that right angle, we now have a right triangle, and we need to find A. In reference to A, we have the opposite and the adjacent. So remember that opposite and adjacent, looking at the right, is tangent. So you should be setting up the tangent ratio. Tangent of A is equal to 14 over 26. And then whenever you're looking for the angle, you have to use the inverse function. So you have to take the inverse function of both sides. And in other words, angle A is just the tangent inverse of 14 over 26. So you pick up the calculator, and you get 14 divided by 26. And you take the inverse function of that. And it tells me that A is 28, a little more than 28 degrees. And this problem is asking me to work to the nearest degree. So we're going to say about, so we use a little squiggle, 28 degrees. Now we're going to practice without the definitions. So we'll keep going, but see if you can remember. Okay, so this next one, you can use trig ratios to find unknown sides lengths of a right triangle. That's what we've been doing with given measures of any side and any acute angle. Remember, you only use the acute angles. So here is, it says read example B in your book, but I've done a lot of examples, so we're going to do example A here. I just need to find X. It's a side length. So I have to think in terms of 42. In reference to 42, I have the adjacent side, and I have the hypotenuse. So adjacent and hypotenuse is cosine. So I will set up a true statement that says the cosine of 42 degrees is equal to the adjacent side over the hypotenuse. Then I turn this into a ratio and proportion, cross multiply, and divide by the leftover. So x is just 11 times the cosine of 42 degrees. Then I just pick up my calculator, go through the same process. 11 times 42 cosine. Okay, and again, you'll have to practice this with your calculator. Every calculator works different. X is 8.17, rounded to the hundredths place. And they don't give rounding directions, so we will just leave it at that. What I should think about before I move on too much is that this is 8.17 and this is 42 degrees. This would have to be 48 degrees. And 11 should be the longest side because it's the hypotenuse. If I wanted to find y, I should get a number that's smaller than 8 because it's opposite a smaller angle. So we could just go ahead and find y. So I could say the sine of 42 degrees is the opposite over the hypotenuse. So 11 times the sine of 42 is equal to y. And so just kind of using number sense, we're going to make sure our numbers make sense. 42, the sine of 42 is that. I'm going to multiply it by 11. I get 7.36. So let me close that. According to my work, y is 7.36. And since y is opposite 42, which is smaller than 48, y should be smaller than x. And then I guess you could also use the Pythagorean theorem to check. So I might do a little estimating. If I did 49, 7 squared is 49, 8 squared is 64, 49 plus 64 is 113, and I've underestimated. 11 squared is 121, so my answers seem reasonable. We scroll down a little bit more. It's the same type of problem. I'm not going to work them all out. Oh, well, actually, this one we had to find the angle, so I will. So I'm going to find z. So in reference to z, I have the opposite and the hypotenuse. So my true statement is sine of z equals 32 over 74. So I have to take the inverse sine of both sides. So what you'll eventually do is you know that, so you could just jump to this step. Sine inverse 32 divided by 74. Pick up your calculator and type away. So 32 divided by 74, take the sine of that, and oops, I'm supposed to take the inverse sine. I knew my answer didn't look reasonable. 32 divided by 74, take the inverse sine of that. That looks like a more reasonable answer for the angle in this triangle. So 25.62 into the nearest degree. If they asked you, you would write 26 degrees. It doesn't say specifically. A lot of times, angles will be round to the whole degree. Okay, one thing you need to understand is terminology. So sometimes you'll hear the term angle of depression, which just is the angle from the horizontal down, or you might hear angle of elevation, which is the angle from the horizontal or the horizon up. And in a word problem, you have to understand how to draw the pictures eventually. So let's look at the picture here. A salvage ship's sonar locates wreckage at 12 degrees, a 12-degree angle of depression. So from the water, so if you didn't have the picture, you would think of the water as just a horizontal line, and it's an angle of depression. So from that horizontal line, you would go down 12 degrees. That's how you would draw the picture if it wasn't given to you, which eventually is a skill you'll need. A diver is lowered 40 meters to the ocean floor. So if your boat was here, you would think that you're going down 40 meters, okay? But the ocean floor is parallel to the ocean if everything was perfectly flat and still. But to solve a problem like this, we would just make the assumption that it's a parallel floor to the ocean to get the answer, a reasonable answer. There might be a little bit of error. Since the lines are parallel, you have alternate interior angles, so you have 12 degrees here. So you end up having a triangle right here. You can use that triangle. You can use that triangle to find the distance. How far does the diver need to walk along the ocean floor? So here's your little diver. He's going to walk along the ocean floor to get to the wreckage. That's D. And then you would just say in reference to 12 degrees, I have the opposite and the adjacent. So I'm going to write the tangent of 12 degrees is equal to 40 over D. And then I would just solve for D the same way I've been solving all along. Okay, this is the last problem. So here, an evergreen tree is supported by a wire. So the wire's right here. That's what that is. Extending from 1.5 feet below the top of the tree to a stake at the ground. The wire is 24 feet long, so that's why they have the 24 there. And it forms a 58-degree angle with the ground, so the 58 is here. How tall is the tree? So the way I would look at this is I would just think of a triangle outside of the picture, just to keep things simple. Take the triangle outside of the picture, but remember that in the end, my final answer, the height of the tree, is going to be whatever I figure out for x. Whatever I figure out for x plus the 1.5. So the tree height is going to be x, which is in my triangle right there, plus the 1.5, because there's a little bit of the tip of the tree above the wire. So I have a 24 here, height is perpendicular, this is 58 degrees. In reference to 58, I have opposite and hypotenuse, so the true statement is sine of 58 degrees is equal to x over 24. 24 times the sine of 58 is equal to x. So I picked up my calculator and 24 times, and I have to put the angle in first for this calculator. Let's clear that out, that didn't work. I'll put the angle in first. 58 sine, that's the sine of 58. You can see that up here. Times 24 equals, so 20.35, and I'm going to make that my x. So the tree height is 20, and I'm going to round to one decimal place. 0.4 plus 1.5, so 21.9, and then the units were in feet. So the height is about 22 feet. And I'm just rounding because there were no rounded directions. That's the basic.